So now that we know what elastic and inelastic means, let's put that into practice. So in this question we have a car of mass 500 kilograms that is traveling at 4 meters per second to the right, and it's going to collide with a 400 kilogram stationary car. The two cars stick together. Determine the velocity of the two cars after impact. Well, here we've got two objects colliding, and so we can use our formula initial momentum, or the sum of the initial momentum is equal to the sum of the final. Please keep in mind that this formula does not get given to you in the exams. You just need to remember this one. Now we're going to choose a direction as positive, and then we open up our system of brackets like this, and so we can just say I'm going to call the 500 kilogram car A, and the 400 kilogram car I'm going to call it B. So we're going to have mass of A, velocity of A, and then I'm going to put an I for initial, or I could use small letter I, doesn't really matter, and then B and velocity of B initial, mass of A, velocity of A, final. I hope by now you know how to use this formula really easily or quite comfortably, and then mass of B, velocity of B, and final. Now we just fill things in. So mass A is 500. Its initial velocity is 4. The initial mass of the car B is 400, but it's not moving because it's stationary. They say the two cars then stick together, so here your teacher might do some like type of factorizing thing over here, or they'll tell you to just make one big bracket. You don't have to, it's your choice, okay? So I'm going to keep it separate, so the mass of the first one is 500, but I don't know what its velocity is. I'm just going to call its velocity V, because I know that the 400 kilogram car is going to have the same velocity. Why do I know that? Because they stick together, and if two objects stick together, they will have the same velocity. On the left, we're going to end up with 2000 equals 2, and then 500 plus 400 is 900 V. The reason I can put them together is that their V's are the same. Okay? Always make sure that that is the case. And so we simply divide by 900, and so therefore velocity of both of those objects is going to equal to 2.22 meters per second. And because I got a positive answer and I chose right as positive, we're going to say to the right. Okay, so the first answer is 2.22 meters per second to the right. The next one is to determine whether the collision is elastic or inelastic. So to do that, we need to work out the initial kinetic energy, and so you just add up the energy. So remember, kinetic energy is equal to a half mv squared. Remember the square, and this formula is given to you in the test, and so we can say the first object was a half and its mass is 500. It was initially traveling at 4, plus we'll do the second object which has a mass of 400, but it was stationary. You can then type this all in on the calculator and you will get an answer of 4,000, and the unit of energy is joules. Then I look at the final kinetic. Let me just write this nicely. Sorry, sometimes I write too quickly and then I leave out letters, as we saw in the previous video with energy. So here we've got a half. Now some teachers, because the two objects are together, your teacher might just say 900 and then you'd say 2.22 squared. See, I've combined all objects into one. But you can do it separately, so you can do it like this instead. You could do the 500 kilogram object, and it's traveling at 2.22 squared, and then you could simply add the other object, which is also traveling at 2.22 squared. You must do whatever comfortable for you. You don't have to follow your teacher's method. If they ever tell you to do that, just ignore them. You are allowed to use your own technique as long as it's comfortable for you. And so either way you do that, if you go type that on the calculator, you end up with 2,217.78 joules. So the energy before is not the same as the energy afterwards. Some of the energy gets lost as sound and deformation, and so this whole collision is inelastic. What I see a lot of students doing for a question like B is they say that the energy, or the kinetic energy, the kinetic energy before, so they go initial, equals to the kinetic energy final, and then they try solve it like that. Guys, that's not correct. No one said that their kinetic energies are equal. You might be confusing that with the first formula, which says that the momentums are equal. The momentums are equal. That's a law that we know from physics. But no one said that the kinetic energies have to be the same. That might happen or it might not happen. You have to calculate each part individually, like this, and like this, and then compare the numbers and see if it's the same.